For example 2, we are going to be given an image here, and oops. This image contains an isosceles triangle. Kind of looks like this. And in the triangle, they have like a lighthouse. No, it's not a lighthouse. It's a tower. It's like a lighthouse. Let me read it. It says, Thales, a Greek philosopher, is said to have developed a method for measuring the distance that a ship is out to sea. He made a compass by nailing 2 sticks together, and standing on top of a tower, he would hold one stick vertically and tilt it until he could see the ship along the line of the tilted stick. With this compass setting, he would find a mark L on the shore along the line of the tilted stick, and then he would use that to determine how far the ship is. So basically, he was in like a tower, right? And this tower was here, and he was standing right here, and he would have a stick. And so, just to kind of set this up, this would like be the sea, and then this along the edge would be the ground, and then somewhere over here there would be some sort of landmark that he would use as a reference. So like, let's say, a happy little tree, as Bob Ross would say. And so there would be a tree here. And what he would do is he would basically use this corresponding parts of congruent triangles to determine the distance from the ship. So there'd be like a ship out here, or a sailboat. And he could determine the distance, how far it was away from the land. And so by standing this tilted angle that he did, what he would do is basically, I probably should have drew the picture first and then put the triangle, but I didn't want to. I wanted to make sure things were somewhat accurate with regards to the scale. So we've got this little. Let me get this just right. So basically from here to here, we have this measurement, and then from here to here we have this measurement, and then this forms like 2 triangles. Right? And so let's label this as it's labeled in the book. We would have S, R, T, and then of course L. And basically what we were given is that he used symmetry, and what's given to us in this image is he used symmetry basically to show that TRS and angle TRL are right angles. And basically that means they're 90 degrees, okay? And so I'm just going to denote this with a big red thing that right here, that's 90 degrees, that's 90 degrees. Maybe I'll do it in black so you can see a little better. So they're 90 degree angles right there. That's good. And then the other thing that we're given is that angles RTS is congruent to the angle RTL. Okay? And so what that means is that up here, RTS, this angle right here, is congruent to this angle here. All right, and he did this on purpose by holding the stick with the compass and determining, making sure that they were symmetrical, that those 2 angles are the same. And so now what we're trying to prove, what we're asked to prove is basically that RS, the length of RS is congruent to the length of RL. So in practicality, basically what Thales knew was that it was easy for him to measure this because this was on land, right? So he could measure the distance from here to here because it was on land, and so he'd have this landmark, right? So he'd have this landmark with a known fixed distance, or other landmarks where he knew the distance, and then he would just swing his compass the other way and try to determine how far the ship was out to sea. All right, so now we're going to be a little more formal on this. I'm probably going to write small because I'm going to try my best to keep the image in full view. All right, so let's prove this bad boy. So the first thing we're going to have are our statements, and then the reasons for those statements, the justification. And so the first thing that we know is that angle RTS is congruent to angle RTL, and that's given to us. Write a little line there so we don't get that confused. We also know that TR is congruent to TR. How do I know that? Reflexive property. We're also told that angle TRS is congruent to angle TRL, because that was given to us. All right. So now what I've just done, whether you guys realize it or not, is I've actually proven that the triangles are congruent. And now that I've proven that the triangles are congruent, it's pretty easy to prove that the corresponding parts are also congruent. So now, I should say given, but I think the textbook says that all right angles are congruent. Okay. So basically, in those steps, the next step I have is that the triangle TRS is congruent to triangle TRL. And that's based on, well, we have the angle, side, angle postulate, right? Angle, side, angle, right? Because we have this, if you redraw the diagram like this, I have that this angle and this angle are congruent. They have a side that's congruent, and then this angle and this angle are congruent. So we have angle, side, angle. Theorem for congruence. And then lastly, because they're the same, I could say that RS is congruent to RL. Easy peasy. And this is because corresponding parts of congruent triangles are congruent. Okay? And so because Thales knew and understood this, if he knew the measurement of the landmark distance from, say, the base of the tower, then he could easily, using the compass and ensuring that the compass had congruent angles, he could determine when the ship was RS distance away.